Welcome to the video lesson for Notes 3, end behavior and concavity. We're going to talk about some properties of exponential functions and use it to help us set up our properties for our logarithmic functions. To begin with, for our growth functions, that's going to be anything with a b value that is going to be greater than 1. And for a positive, meaning that our a value is greater than 0, when we look at what our graph is going to be like, we know it's going to be exponential growth, and we know that we have a horizontal asymptote at 0. So when I go to sketch this function, it will look like this. For our negative value, we know that our a value is going to be less than 0, and that's going to be a reflection across our x-axis. So when we go to sketch our function, we want to make sure we're reflecting it across our x-axis, and we will see something looks a lot more like this function. For the k, we have, I'm here for it. When we go to sketch that function, again, our normal decay function is going to be a decreasing function. Again, we have that horizontal asymptote of 0, so it will look like this. When our a value is negative, once again, we're going to have a reflection across that x-axis, and so our function will look a lot more like this. Looking at these functions, we know that our logarithms are inverses, so we're going to go ahead and use that inverse property to kind of sketch that function. For our first log, we know that we're going to have a growth function when our b value is greater than 1. And when we go to sketch that, we have a vertical asymptote at x equals 0 now. So our function is going to be looking like this. If we have a negative logarithmic function, that means that we have some kind of negative value in front. In this case, it'd be an a value. We need to know that a is going to be less than 0. So once again, we're going to have a reflection across our x-axis. So we're going to have something that looks a little bit more like this. For decay, once again, we're going to see that our b value is going to be between 0 and 1. When we go to sketch our decay function, we still have that vertical asymptote. So our function is going to look more like this. And then again, when we have that negative, meaning that our a value is less than 0, we're going to do that reflection across our x-axis, and we get something that looks a little bit more like that. What we're going to do now is looking at some graphs. We're going to try and describe the behaviors of our logs, whether it's increasing, decreasing, concave, and then what's happening with their left and right behavior. Okay, so let's look at example number 1. Looking at example number 1, I know that it is increasing for the entirety of the graph, but this has a restriction on its domain because of that vertical asymptote. So it's going to be increasing, but it's increasing from 0 to infinity, not decreasing at all. We can also say that it's definitely concave down. Again, it's going to be concave down from 0 to infinity because of that vertical asymptote. And then for our behaviors, if you see on the left side, it's going down, but this is going to be a one-sided limit because it's on the right side of 0. So when we look at this, it's going to be the limit as x goes to 0 from the right side, again, because there's no left side of that 0. And our function is going down, so we have f of x is going to equal negative infinity. On the right side, we see the function is going up, and this one doesn't have a one-sided limit because it just keeps increasing regardless of what side that it's on. So for this one, the limit is going to be as x goes to infinity, and since our function is going up, f of x is going to equal infinity for that one. Looking at your turn A, go ahead and pause the video now and attempt to find all of the properties of our log, and then check back in and see how you did. All right, let's see how you did. So we can see this function is definitely decreasing. So we know it's increasing again from 0 to infinity because of its vertical asymptote. It is concave up for the whole portion. So again, 0 to infinity. And then on the left side, again, we know that on the left side, we're approaching 0, but we're approaching 0 from the right side, which is why we have the 0 plus. And because our function is going up, I know that it's going to have a limit of positive infinity. And then on the right side, again, it just keeps going down, 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 down. So we know that the function is going to have a limit of negative infinity over there. All right, looking at example number 2, now what we're going to do is attempt to look at a function and get a quick rough sketch of it to determine what the shape looks like, and then use that shape to help us identify what our features or properties are. So to begin with, I look at specifically my A value. In this case, I have a positive A, and that tells me there's no reflection, so I don't have to worry about any kind of changes there. And then I have a x minus 1. Now, x minus 1 is going to be a horizontal shift. Remember, for all of our horizontal shifts, we're going to shift in the opposite direction. So I'm going to go to the right 1, which means when I go to sketches, I have a different vertical asymptote than what I normally would have. Again, we're going to shift everything to the right 1. So my vertical asymptote now is going to be at x is equal to positive 1. And then when I go to sketch my function, it's going to be a normal log function, just shifted to the right a little bit. There is a stretch because of that too, but in terms of sketching it, we don't care about what that stretch does because we still get the idea of the shape. For our domain though, because we had that shift, our domain now is going to be from 1 to infinity. Our range is going to be from negative infinity to negative infinity because there's no restriction on the up and down movement. Looking at our graph, I can see that definitely is increasing. Again, it's increasing for this adjusted domain because of our horizontal shift. It is not decreasing at all. This one's going to be concave down. And then again, we're going to look at our limits here. I can see on this left side, on the left side of the function, but the right side of our asymptote, it's going down. And again, when we go to write this limit, we are approaching that vertical asymptote of 1, but we're approaching it from the right side. So we got to put that plus sign up there. Again, this is a one-sided limit. And because it's going down, we can say f of x is equal to negative infinity. On the right side, the function is definitely just kind of going up. So for our right-sided limit or right end behavior, we have the limit as x goes to positive infinity. Again, this one's going up, so f of x is going to equal a positive infinity as well. All right, I'm going to go ahead and sketch this next one with you, and then I want you to go ahead and pause it and try and find all of the answers for it. We have a couple things going on here. We have a negative in front that's going to do a reflection across the x-axis. We also have a plus 2, so we know we're going to have a shift there. That plus 2 is going to be a shift to the left of 2. And again, this negative sign is going to go across the x-axis. So when I go to sketch this function, I have that normal increasing log. I'm shifting it to the left 2 to get that new vertical asymptote. And then I'm going to have that normal shape but reflected across the x. So now it's going to look a little something kind of like that. Okay, go ahead and try and answer the questions for domain range, increasing, decreasing, concavity, and end behavior. Hit pause now and then check back in and see how you did. Okay, let's see how we did. So we can see again that on the left side, we are approaching that vertical asymptote, but we're approaching it from the right side, and we're going up. So that limit as x goes to negative 2 from the right side is going to be positive infinity. And then the limit on the right side, we can see the function is definitely going down. So we have the limit as x goes to positive infinity. We're going towards negative infinity because we're going down. We see that this is a decreasing function and it's concave up. Both of them going to be from negative 2 to positive infinity because that is our new domain based off of the horizontal shift to the left. And then range is going to be from negative infinity to positive infinity. Okay, that does it for this portion of the notes. Go ahead and get started on the homework and good luck.